Hello and welcome back. In our last session, we created persistent volume manually. This static provisioning is a great way to learn, but it has a major bottleneck. An administrator has manually created a PV for every single request. This is slow, tedious, and doesn't scale. Imagine a developer need a 5 GB of storage for a new database. They have to fill a ticket and wait for you, the administrator, to crave out to storage and write a new PV manifest. This is where dynamic provisioning comes in, and it's a modern automated way to handle storage in Kubernetes. Understanding storage class. The heart of dynamic provisioning is resources, call it storage class. Think of a storage class as menu of a storage option that you as administrator offer to your developer. Instead of pre-cutting every stake, you just write the menu. We offer replicated storage and backup storage. Storage class define type of class of storage. This could be fast, like backed by premium SSDs, or replicated, backed by system that replicated data across multiple nodes for high availability. The most important part for a storage class, it is provisioner. The provisioner is the real worker. The provisioner is the name of the chef in the kitchen, the actual software that knows how to fulfill the order. In cloud environment like Google Cloud, the provisioner would be something like Kubernetes / GCE PD. For on-premise or self-hosted environment, this is where the solution like Longhorn or Ceph using Rook come in. These are powerful software-defined storage systems that run inside of your Kubernetes cluster. When you install a solution like Longhorn, it is also install its own provisioner, typically named driver longhorn.io. By default, the Longhorn also installs two storage classes of its own to your cluster. This is what makes Kubernetes so practical. The storage class is generic abstraction, and you can plug in any storage system, for a simple host path to a complex replicated system like Longhorn or Ceph, as long as it's provided as a provisioner. Installing a provisioner, Longhorn. So how do we get a powerful provisioner like Longhorn into our self-hosted cluster? Let's walk through the installation for Longhorn. The most common and manageable way to install it is with the helm. So the requirement for Longhorn in Debian operating system is to having the open iSCSI. So this is the requirement. I already fulfilled this environment in my system. And then we need to add the repo of Helm of Longhorn into your system. It's already been there. And the second step is to installing the Longhorn into the Longhorn system namespace. Basically, this is a de facto name for Longhorn system. So it's easier to track the pods running on that namespace. I already did that. So Longhorn is installed in that namespace. So I'm getting the pod in Longhorn. As you can see, this isn't a simple single pod application. Longhorn is a complex distributed storage system. It's deploying a manager, a UI, and most importantly, a daemon set that will run a Longhorn instance manager pod on every single node in your cluster. This is how it discover and control local disk on each node. We must wait for this process to fully complete before we can use it. We can watch this pod come online in Longhorn system namespace by this command. Let pause and -n. Alright, now that all of the pods are running, the Longhorn system is active. It has registered its driver provisioner with our Kubernetes cluster, and we are now ready to use the storage class that is created. So the third step is using a storage class. Now let's see the payoff. Let's become a developer who need 1 GB of the new replicated storage. We don't file a ticket. We just write a persistent volume claim. So right here, I have the Longhorn PVC. This YAML is almost identical to the PVC, our static provisioning lesson, with one new magical field, spec storage class name Longhorn. This is developer ordering from menu. They are saying, I need 1 GB of storage and I would order it from the Longhorn menu item. Let's see what happens when we apply this. This is a dynamic provisioning moment. So I'm going to use k-apply-f Longhorn PVC. As you can see, that DB PVC created. Now watch this. It's immediately asked Kubernetes to show us both PVC and PV. So I'm getting the PV and PVC. This is incredible. Let's break it down. We created one object, PVC named dbPVC. Just 2 seconds, you can see that persistent volume automatically appeared. Look at the name. It's PVC 44B8 and then it's ending with 71. So this is dynamically provisioned PV created by our Longhorn provisioner. The status for both is bound. The PVC has been matched and bound with the new PV. The PV reclaim policy is delete. It's defined by its own storage class. As you can see here, the reclaim policy for PV is delete. So our dbPVC volume field point directly to this new PV. As you can see, this is the PVC and it's pointing to this volume. So this is the name of our new PV. This is the entire workflow. The administrator job was to set the factory, install the Longhorn, and create the storage class. The developer job was to place the order, the PVC. Kubernetes and Longhorn provisioner handle the entire manufacturing and delivery process automatic. Let's go back to the presentation. And from this point forward, for your pod, nothing changes. You just created your pod and mount the persistent volume claim named dbPVC, exactly as you would have in the static provisioning world. This is standard, modern, and scalable way storage is managed in Kubernetes. Administrator define what kind of storage are available, and developers simply claim what they need when they need it. Thank you for watching, and I'll see you in the next topic.